welcome to Scratch Quiz. Today in our Take from Zero series, we'll be learning about number system in day 2 of digital logic. So let's start. So we have all read the definition of computer, that computer is an electronic device that accesses user data, process it and give meaningful result. In the definition, we say a computer is an electronic device. An electronic device. So do you think an electronic device understand our human language? For example, a fridge is an electronic device. Does a fridge understand our human language? Obviously no. An electronic device only have two state or understand two state, on and off. We can either on the electronic device or off the electronic device. There is nothing more than that. But wait, we have learned for a lot of time that this on and off turns into fully working computer. How come? So the first step of turning simple 0 on and off into a working computer is number system, or mainly binary number system. So what is a number system then? Number system is an way of representing a number, just like we did in math, prime number, whole number. But in computer, number system is mainly four types: binary number system, decimal number system, hexadecimal number system, and octal. These are four main number system in the computer, which you will find in other topics too. Among even them, binary number system is one of the most important number system, as this is the building block of computer. This number system is used to make the computer which you see around the world. This number system is the block of everything. So as we have said, computer is an electronic device which doesn't understand a human language and can only understand this two state, on and off. So we can conclude that a binary number system is a number system that shows two state, on and off, where the on is denoted by the number 1 and off is denoted by number 0. Binary number system is called a base 2 number system 2 because it has two numbers, 0 and 1, in which 0 is off and 1 is on. Engineer people assigned 0 as off and 1 as on to later build a fully working computer with other parts such as logic gates and other stuff. So binary number system is a block, is the very building block which holds the computer from the very foundation. But we have other number system too, right? How does this other number system work? Binary number system is the only number system that is used to build the computer foundation. The other three numbers, such as we have discussed, decimal, hexadecimal and octal, doesn't play part in building the computer. If only binary number system is used to build the computer and no other number system is used, and it is only way of building a computer, why use the other number system, or why is there even other number system? Because 0 and 1 is also considered machine language is really complex, really long. To write even A, there needs to be several of 0 and 01. That's really hard to understand for people. It's long, complicated. To make it easy to understand, for a human to understand easier, the other number system, hexadecimal, decimal and octal is used. That's it. Simply, these number systems are used because it helps us understand the binary number system better. It shortens the length of the number system by a lot, and a programmer who is looking into that can easily understand that. That's why hexadecimal, decimal and octal is used. Among them, hexadecimal consists of 16 digits, decimal consists of 10 digits and octal consists of 8 digits. To give you a view, Binary have two digits, 0 and 1. The hexadecimal has 16, decimal has 10, and octal has 8. Let's start with decimal. Decimal has 10 numbers, 10 number where it start with 0 and ends with 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Octal has 8 digits in which it starts with 0 and ends at 7. 0, 1, 2, 3, 5, 6, 7. The hexadecimal on the other hand is a little different because it starts from 0 to 9 plus it goes from 10 to 16, but it is not labeled as 10, but it starts with the alphabetical letter A, and it starts with A, B, C, D up to E. That's why it is called hexa plus decimal. Now let's go to the conversion of number system. In conversion of number system, we learn conversion of binary number system to other number, hexadecimal to other number, decimal to other number, and octal to other number. Let's start with binary number system with other number. Let's start with binary to hexadecimal and octal number system. I have put hexadecimal and octal numbers at same place because teaching them at once is a lot easier because you understand it more clearly, as both uses the table method, as there is no formula for taking out hexadecimal and octal number system. So let's start. As you can see here, I have already drawn the table. You can see the table in Google or other two, where searching binary to hexadecimal or octal number system will give you this table. So in the table you can see it goes from 0, 1, 2, 3, 5, 6, 7 and A, B, C, D, E, F. So as we have said, decimal is from 0 to 9. So 0 to 9 is up to 0 to 7 is octal number system. So up to this is what we need for octal number system. But for hexadecimal number system, we need up to F, which is up to here. So let's understand the table. In the table you can see that it starts with 0 and it is equal to 0. It increases from 0, 0, 1, which equals to 1. Then it increases to 10. Then it increases to 11. It increases to 100. It increases 101, 110, 111, 1000, and so on. What is happening? Are you confused? Let me clarify and tell you what really is going on here. So here, what is happening is the number is increasing by 1. You might not see it, but it is increasing by 1. For example, in here 0, 0, 0, 0, let's start with here, plus 1 will give us 0, 0, 1. Let's add another 1. 1 plus 1 is 10, as we have learned in binary arithmetics. 1 plus 1 is 10, so it becomes 10. Again, if we add 1, it would be 11. Let's add 11 with 1. What would it give us? 1 plus 1, 10. 1 plus 1, 10. It gives us 100. So if next would be 100, right? Yes. So you see the pattern, it is increasing by 1. It goes on, and so if in exam or if you don't have a calculator to convert a number directly, you can use this number of adding the number if you know the binary arithmetic and easily get the table. So yeah, I hope you understand the table. Let's move on to conversion of the hexadecimal and octal number using this table. Let's go to our first question. Which question should I do? Let's do the question 1101101101 dot 1101. I have also put the fraction part to make it quicker. What should we do? Should we do octal or hexadecimal? Let's start with octal. Octal, binary to octal. In octal, we have said time and time again, it is a group of 3. What do we mean by that? What we mean is grouping the binary number system or the number system into 3 groups each. So in here number in here before the decimal in whole number system, what we do is group this number into three parts, which is 101, 110 and 110, 2110 and 1101. Here, as there is perfect group of 3, we don't have to do anything. But let's say if there was an extra 1, what would we do? The 1 is, we don't have any group, we are in trouble, right? No. So in whole number, as we have read in placeholder chapter 2, whole number, the number increases from left to right. So we count from left to right. So 101, 011, 011 and 1. So they, as there is no group, there is not a sufficient group of 3 and there is 2 number missing to make group of 3, we just do is add the missing number with 0 to make the single number or the single number into group of 3. If there was 2 1, we would just add 1 0, but as there is value 1, we will add 2 0 to make it a group of 3. So I hope you understand that if there is if there is a number that doesn't have a group of 3, what we just have to do is put the 0 in front. We have to count from our right to the left, not right left to the right, but right to the left, and when counting, if there is a insufficient number, we just have to add the 0. So after adding this, let's convert it. Let's convert from right to the left as we have done. 101 would be 5, 110 would be 6, 110 again would be 6, and 011 is obviously 1. Then what about the decimal part? Do we have to do different calculation? Obviously no. Again, just like the whole part, we just have to do is group it into 3 parts. Again, there is insufficient group. What do? Do we add group 0 in our left side? Obviously no. What we do is we have to add 0 in our right now. It is just opposite of the whole number. We added 0 in our left all the time in a whole number, but we have to add the 0 in right in whole in decimal number system. Sorry, left. So it would be 110 with group of 3 and 100 with another group of 3, which is obviously 6 and 4. So the answer of converting this number 110, 110, 0101, 1 dot decimal 110, 100 is 1665.64 with a base of 8. Now let's turn the same number into hexadecimal number system. 110110101 110 base of 2 into a base of 16. So how do we convert that? It is very similar to octal number system. Same as that, we take the number from the table. We can take the number just like 110 and see if the 110 in the table and see that 110 is 6. So we just take the number and see what number it is and put the number. Just similarly we do in hexadecimal. We just do that, but in hexadecimal, as name suggests, rather than group it into 3 parts and not just like octal, we group it into 4 parts. So after grouping, let's first group the whole number. Again, to group a whole number, we start from the left, right, and go to the left. So it would be 1010, a group of 4. Then let's group another 1101, a group, another group. Now there is only 1 remaining. Just as octal, we just have to add the remaining 0 or remaining number with 0. If there was 3 1 but 1 number missing to make it group of 4, we have to add just 1 0. but as there is only one, we have to add 3 0, so it would be 0 0 1 1 0 1 1 0 1 0 1. And let's fast convert this. 1 0 1 0 1, which is 5. 1 0 1 1, which is 1 0 1 1, which is 11. But wait, 11 is also called B, or it is called B. So rather than writing 11, we have to write we have to write B, and 1 is obviously 1. Now let's go to the fraction part. Just like in octal, we have to group into 4 parts. As there is perfectly 4 parts, we don't have to worry about that much. We have to just see the table, which is 1101, which is, let me see again, 1101, which is 13, or D. But let's say if there was another extra number, just like actual number, we just have to add the 0 number to make it the group of 4, which will give us 8. So the answer would be 1b5.d8. I hope you understand the conversion of binary number system to hexadecimal and octal number system. In summary, what we have to do is see the table. If we wanted to make the table, we just have to add 1 from 000 to the number we want, and after making the table, we just have to do is see the table, and after grouping and adding the missing number or adding the 0, we have to convert the number. I hope you understand. But now let's convert the other number system into decimal number system. Let's start with the binary. How do we convert the decimal number system into binary number system? For example, 30. It has a base of 9. We have to convert of 10, and we have to convert it into base of 2. Wow, what do we do? In conversion of any number from binary to binary to decimal, or hexadecimal to decimal, or octal to decimal, it doesn't matter. For converting any other number into decimal number system, we have to do is multiply the given number or the decimal number system and the given number with the base number system of that number. So for example, let's say I have a number. Let's say I have a number 11011. Let's say I want to convert this into our decimal number system. To convert the binary number system into the decimal number system, what we do is, as I have said, we have multiplied the number, which is 11011, with the base number system, but we multiply them, each of them, so 1 into 2 with the base number system. Base meaning the number, how many number it has. So in binary number system, as it has a base of 2, we put 2. So 1 into 1, 1 into 2, plus 0 into 2, plus 1 into 2, plus 1 into 2. Now what we do is in here is that in this number system, or converting any other number to decimal number system, after seeing the number, we multiply the number with the base number, each of them is number with the base number, and increase the power from left to right. Put the power. For example, at first it starts with 0, then it increases from 0 and 0, 1 2 3, and up to, as it is up to 4, you have to put up to 4. Let's say if there was on a decimal number system like 101. Now what we do is put the 1 and do the same just like whole number, but in decimal number. In decimal, what we need to do is start with -1. After 0, it start with -1. Just like in placeholder we have read, it start with -1 and goes on to -2 and -3. So in summary, what we need to do to convert any number into binary number, into decimal number system, is multiply with the base number system and put the power, and the power increases of whole number from right to the left. It increases as it goes from right to the left, and it decreases as it goes from left to the right. and in decimal the power becomes minus, and so on. So let's take out the answer. The power of 2 would be 16, the power of 3 would be 8, the power of 2 would be 4, and power of 1 would be 1. 2 power 1 is 2, and 1 power 2 is 2 power 0 is 1, and in decimal it is 0.25, I think. 0.5, 0.5 plus 0.25 and 0.50. I think that's the answer. I think that's the answer. Now what we do is take the answer, which would be 16 plus 8 plus 0 plus 2 plus 1. So the answer would be 16 plus 8, that gives us 24, plus 2 plus 1, 26, plus 2, 28. Fraction is, after adding the fraction, just put the fraction part here. Now it's very similar to octal and hexadecimal. In octal, what we need to do is, for example, if there was a number 23, we just have to multiply each number with the base number. So as we did in binary, which in octal the base number is 8, so multiply by 8, and just like that we put the power from the left, so 0 and 1. In hexadecimal 2, what we do is multiply with the power with the base number, which is 16, and in 3 it is again 16, which is, and put the power which starts with 0 and it increases. This is it. This is the way of converting any other number into binary number, into decimal number system. I hope you understand. Now let's convert a decimal number system number into other number system. As we have did other number to decimal number, it is just that but opposite. In other to decimal number system, what we did was we converted the other number to decimal by multiplying with the base number. But for converting a decimal into octal, we just make that opposite by dividing with the base number. What do I mean by that? Let me tell you. For example, we got the number 13, decimal number system. We have to convert that into binary number system. Previously, to convert a binary number system into decimal, we multiplied it with the base number, which was 2. But now what we do is divide the number, because we are doing the opposite. So the decimal, we divide the decimal number system with the base number system, in which binary number is base of binary number is 2. Here there is a little bit different. So when we divide the 2 with 13, we cannot obviously divide the 2 with 13, so we divide with the less, but with 2 6 are 12. Now we put the remaining number by subtracting the number we get from multiplying the number with 13 would, after multiplying 2 6 are 12, 12 minus 13 would give us 1. This is a reminder or the answer we will get. So 2 can perfectly divide 3, 2 3 is 6, there is no remainder, so 0. 2 1 is 2, there is remainder of 1. Then 2 0 are 0, and there is remainder of 1. So answer, after that what we do is, we get, after doing the division, most people get confused and write the answer from the top, but that is wrong. In the division of a number, in whole number, what we do is take the answer from bottom to the top. So the answer would be 1101. This is pretty similar to octal and hexadecimal too. For octal, as the base number is 8, we divide the 13 with 8. 8 multiplied 2 is 16, it is too much, so we multiply 8 with 1, which will give us 8, and it would give us the remainder of 5. 8 0 is 0, and it would give the remainder of 1. So the answer would be 15 for octal. So 13 is equal to 15. Well, let's say I have to divide 13 with convert the decimal into hexadecimal. To convert decimal into hexadecimal, just as we did for converting octal or binary, we divide with the base number. For it is 16. As 16 is bigger than 13 already, what we do is 16 is a 0 and it has a remainder of 13, so 13 is equal to 13. But let's say it is a bigger number 20, which is not equal to the decimal number system. So let's do 16 1 is 16, it is remainder of 4, and 16 there is a 0, remainder of 1, so 20 decimal 20 would be 14. So in summary, converting a decimal number to other number is basically dividing the number and writing the answer or writing the remainder as answer, and we must always count the answer from bottom to the top. So the answer is 14, answer is 6 13 and 16. I hope you understand. Now let's go to little bit complex part. It is same we'll be all doing decimal to other number, but what for fractional part. What to do with the fractional part? Let's give example 0.625. It is same for other, just like how converting a decimal number to other number system is dividing with the base number of what we are converting it into. We have to multiply that. Now we have to multiply with the base number. So let's say we got the number 0.101 in our decimal and our binary. Okay, let's do hexadecimal for now. Let's say we have got a number 6 to 5. Let's convert this fractional decimal into fractional hexadecimal. What do we do? I will give you a table that will make this calculation really easy. What we do is say fraction, pick this table, call one thing called fraction, then other thing called process, another called fraction process, let's call it result, and after result we divide it into fraction and integer. What do we do in this figure is we put the fraction that we get, then multiply the fraction with the base number. In hexadecimal the base number is 16, so multiply 0.625 into with 16, which will give us 0.625 multiplied 16 would give us perfectly 10. Now here's the integer is 10, so it ends here. But let's say I have got a different number. Let's say I have a number that is smaller, 0.25. 0.25 multiplied by the base number, again it would give us 4. So let's say if, for example, if you multiply the fraction part with the base number and it gives us the perfect result called 4, and there is no fraction, we have to go until there is the 0 fraction, and yeah, that would be answer. So converting 0.625 is basically the answer would be 4. Now let's convert the same number into our hexadecimal number system. Let's go with other numbers like let's say 1 2. Let's do the number 0. Let's say there is a number 0.2. So this for now. Let's say there is a number fraction part 0.12. How do you convert it? let's say we are converting the octal number system into hexa into binary into decimal number system. What do we do? Just like what we have said, we do is multiply the fraction part 0.12 with the base number, which is 8, which will give us the result 0.96. Now here we can see there is a fraction, but there is no integer. So if there is no integer, we just say 0. So 0.96. Again, what we do is put the fraction part, which is 0.96, which we got the result. Again, multiply the 0.96 by the base number, which is 8. So we multiply the base the fraction of the result part until we get the perfect result 0. So let's say we got the 0.96 multiplied by the base number 8, which will give us 7.68. Here the fraction part is 0.68 and the integer part is 7. Let's again multiply 0.68 multiply 8, 0.68 multiply 8 would give us 5.44. So again the fraction part is 0.44, where 5 is the integer. Let's again multiply 0.44 with 8, which is the base number, will give us 3.52. So 0.52 multiplied by 8 would give us, so as we can see here, there can be an infinity case where the fraction can never be 0, or there is long process of getting the 0. In that case, what we can do is just end with a small letter rather than writing a long 4, 6, 5, 7. We can just end with some when if there is condition like this. So I hope you understand that when converting a number in a decimal number system into any other number system, what we need to do is divide that, and after in dividing, what we need to do is after divide we have to put the remainder in the side and count from the bottom. And for the fraction part, what we do is for any fraction, for octal, for hexadecimal, or a binary number system, what we do is create this table, or this table is for your easiness. You can create or not create, this in your hand. After creating this table, what we do is put the fraction part in fraction table and multiply with the base number, or the number that we are converting it into. We get the result. If the result is not 0, we keep on multiplying with the base number, and if you get the integer, we put in the integer part. The integer is our answer. And here we used to count, or in whole part we used to count from bottom to top, but in here what we do is we count from top to bottom, as it is after the decimal, and this in decimal everything is opposite. So 0, 7, 5. I hope you understand. Now let's go to other simple calculation, that is converting a hexadecimal to other and octal to other. Converting hexadecimal to binary and octal to binary is really same. It is just same as other, because when converting binary to hexadecimal, we look at the table and group them into 3 parts and converted them into looking the table. It is same, but we just do the opposite. It is also same for the octal. What we do is we group into 3 parts, or for example, if there are 13, we just look into the table and see what this number really is. Then for converting a hexadecimal into decimal and octal to decimal, we have already read. We multiply with the base number. For hexadecimal it is 16, and for octal it is 8, and put the power increases from right to left and decreases from left to right. I have said the opposite. It increases from left to right and it decreases from right to left. Sorry for my mistake. So yeah, and after, to convert a hexadecimal into octal and octal into hexadecimal, we cannot convert directly. So what we do is first convert the hexadecimal into binary and then convert the binary into octal. The same for octal, we cannot convert directly, so we convert by octal to binary and then only convert the binary into hexadecimal. I hope you understand the conversion of a number system. It is very simple and it is only used in some way. It is why I learned this is because I needed to learn the foundation of why number system is needed, why it is converted, and why it is needed for the form to build my foundation. I hope you understand. In summary, number system can be converted in different way. So yeah, I hope to see you on the video. In next video, we'll be learning about components, the ones complement, twos complements, and then I hope that this memory. There is other thing like a fractional part, integer part, floating numbers, many other stuff, and of course logic gates. So yeah, I hope to see you in your next video very quickly. Not hope, I will see you in your next video.